Good day everyone. This is my group member. I'm Command Jun. We are here to present our IED principle project for how to extend the lifespan of the meat. Okay, so this is the flow chart of the process. So the first one is from the start day. So we're going to switch on the power supply for each unit. After that, we're going to have vacuum packaging the meat. So we are using the manual operation to do the vacuum packaging to remove all the microorganisms and prevent the fungi and bacteria going in. Okay, so next I would like to pass to my friend Fridaus.
We vacuum packaging the meat. We move to the next step, which is the built-in cooler unit and fan motor unit is switched on by a programmable PID controller. And after that, it will delay about 15 minutes. Then the temperature and the humidity measurement in the freezer carried out by the sensor unit. Next, the PID controller start to process the sensor data. And after the PID controller start process the sensor data, the IoT device transmit the sensor data to the cloud and received by the computer for further analyzing.
After that, the humidity level measurement carried by humidity sensor unit. After that, the controller start analyze the suitable humidity level for better cooling system. Then is ice flows form a log. If no, we will go to C. If yes, we will the controller switch on dehumidifier. We will go to B.
Good evening everyone, my name is Ding Jingbing. Yes, 18149. Now I would like to talk about the process C. C is the process, the temperature measurement. So first, the temperature sensor will measure the temperature level of the freezer. So if the temperature less than negative 15 degrees Celsius and more than negative 20 degrees Celsius, so it will go to N. So this means that the freezer is in the ideal range of temperature. If not, it will start to process. So the PID controller will ask about is temperature less than negative 20 degrees Celsius. If yes, the PID controller will reduce the freezer temperature by reduce the voltage input to the fan motor and the powder cooler unit. Then the IR sensor will start motor angular speed measurement. The controller will start analyze the suitable motor speed for better cooling system. And it will delay about 10 seconds and you go back to process C. You look again. So if the temperature is not less than negative 20 degrees Celsius, so the PID controller will ask again, is temperature is more than negative?
Okay, so this is the problem statement of our project. So our problem statement is we have to extend the shelf life of meat and then avoid the process of condensation. After that, we will using a vacuum sealer machine to seal the meat. So after that, we will remove all the oxygen from the packaging and place the meat into coolest area. So the purpose we put the meat into coolest area is because to prevent the microorganism growth up. Okay, so this is the fish bone, the cause of problem. So the person in this problem is maybe during the project we have an insufficient amount of workers, and then it's also maybe caused by the untrained workers and also human mistake. Human mistake is like measurement by ruler. Okay, so the second cause of the problem will be method meaning the method that we use is wrong sampling or wrong calibration and also the reactive maintenance. Okay, so of course there's also a cost from machine itself. So what is the cost of machine is, maybe the will cause the bacteria growing to the meat itself, and so we have to find a coolest temperature to place it, and cannot be in the hot temperature. So we have to make sure the things that we design is in the coolest temperature as we can. Okay, so next I would like to pass to my partner, Firdaus.
Okay, next we move on to the requirement of the machine itself. So in our machine, we need to have a machine that be able to absorb the air, oxygen, or out of the packaging, which is button operation. Which every our packaging have an oxygen, so we need to have the machine to absorb the air out from the packaging. Next is the manual control system. Then is also need to be the closed loop system. And lastly, the requirement of the machine is involved by the multidisciplinary field of study, as example as electrical, electronic, and mechanical.
Okay, so this is our sketching of ideas. So the option one is designed by one of my member, Jing. So this machine is include Arduino humidity sensor, temperature sensor, and also buzzer inside the machine. Okay, so and this option 2 is designed by one of my group member, Firdaus, and it using the stainless steel material, transparent screen, and also the fan. So the fan is to reduce the heat, and it will produce the coolest temperature inside the machine. Okay, so this is the option 2, and one more is option 3. Okay, so this option 3 is designed by my group partner like Jing, and also me. So we combine the idea, okay, of option 1 and option 2. So we combine it to make a microcontroller interfacing and controller. So the design is actually from the option 1, the option 2, which is the material stainless steel, and then we have a fan dissipating, the thermal dissipation fan, and also we are using the metal casing, and inside the metal casing we have a dehumidifier, and also Arduino control with 12 volt DC supply. So the thermal dissipation fan actually is a pellet as a two-sided fan. So the inside part is to make the coolest, produce the coolest area. So the outside part is for dissipating the heat. So it will emit the heat to outside. So you can see the heat sink arrow there. Okay, so it will produce the cool air inside. So it will blow the cool air inside and eliminate the heat to outside. Okay, so lastly, this is our decision matrix based on those few selection. So we would like to say we will choose solution 3 with we will value it to 15 marks. So because of the safety, the cost efficiency, the elegance, and the easy for maintenance use compared to the other solution. Okay, so lastly, I would like to pass to my friend to explain the mechanical part.
Basically, they have a lot of software that can be used to draw the mechanical drawing. So we have decided to use the Kadia software to draw this drawing. Actually, we know that this is a fan, and beside of the fan is flat. This is a view of the water cooler from the top, and this one is from the front side, and in the middle one is the whole part of the water cooler.
Okay, so this is our electrical circuit drawing part. So now this is our PID controller, which is temperature, humidity, motor control. It control all things. So our output is motor, the motor, fan motor, pellet cooler, which produce the coolest air to the freezer, and then this our temperature, humidity indicating light. So indicating whether the temperature is low or high, or humidity is low or high. So another output is the dehumidifier. If the ice form a lot, so the controller will start to switch on the humidifier until the ice flow is reduced. Okay. So we use two sensors, which is temperature sensor and humidity sensor. So another sensor is IR sensor. So IR sensor is used to measure the angular velocity of the motor. So the IoT device will transmit the data to the computer for further analyzing. Okay.
Okay, so this is about the costing of our project. So the costing is actually estimation up to 27th of November, because maybe in future we still have other stuff to add in. Okay, so for now, the thermoelectric power generator pelleter will cost about 13 ringgit 90 cents, and then the site is 4040, which is a square sheet. So the second one will be the semiconductor refrigerator cooling system. It's a thermoelectrical pelleter also. It's attached to the side of the cabinet. So it will cost around 44 ringgit and 60 cents. And then the third one will be the humidity meter with the LED light display, which costs about 47 ringgit 90 cents. And then we also have using the smart dehumidifier, which costs around 72 ringgit and 19 cents. As you can see in the option 3, so the number 4 option is actually a small box we located on the right side of the cabinet. And then the fifth one will be the motor that we need to use for the encoder. It costs about 589 ringgit. So the last one will be the stainless steel cabinet. It costs about 302 ringgit. So the stainless steel cabinet, we are using the material to build up the cabinet, and then the size will be 40 cm times 6. Okay, so that's all present from us, and special thanks to our lecturer and my fellow groupmates. Okay, so that's all from us. Thank you.